I'll introduce myself. I'm Andrew Weiss. I'm one of our solutions engineers over at GitHub, which is now part of the Microsoft family. I've been with GitHub for almost a year now, and I'm working predominantly with our federal government customers, mostly in the civilian space, and helping them onboard into DevOps and DevSecOps methodologies, and talking about how that fits into the Microsoft ecosystem, of course, to meet mission needs. Harshal?
So I'm Harshal Dharia. I'm actually an Azure specialist at Microsoft. So my role is basically talking about app innovation. So we're talking about DevSecOps, containers, and all that. I primarily focus on the DoD sector of Microsoft. So I work across DoD, helping them embrace DevSecOps.
Go for it.
So let's get started. So I've been at Microsoft for a few years, but before that I was a former software engineer. I did a lot of work for the federal government. And some of the biggest challenges that I saw has been basically siloed, disparate environments. Anybody can raise hand and say, hey, my code works in dev, but does not work in production. I've had several issues where I've spent nights debugging production deployment issues. And that's one of the biggest challenges. And another thing is basically lack of agility, right? So we want to deliver for our customers, and we want to deliver for our customers as fast as possible. But the current processes that we have make it impossible for us almost to do that. And then another thing is basically factor security approaches. We think about security as an afterthought. So how many of you guys do port 45 scans, but do them right before we go to production deployment? Right? Security is never thought in or never baked in when we actually start talking about doing software development. That's a big approach. Another thing is basically, the last point is aggregate emission data. We have a lot of data that our applications create, but we're not able to leverage it appropriately. So how do we kind of resolve all these issues, go faster? One of the biggest things is DevOps, but if you think about it, there's a paradox, right? Now think about a car company making cars as fast as possible, but the car is not turning out to be good quality. That's where we kind of lay the issue out. So basically we're talking about speed and control, basically deliver software as fast as possible to our customer base, but also with increased amount of quality without sacrificing security. This is a great slide from basically, it talks about lines of code. So since I covered a lot of stuff on the DoD side, this is the latest and greatest F-35 fighter. And it's talking about basically how many lines of code are in F-35 compared to the previous generation fighters. And as you can see, as technology is evolving more and more, the lines of code is also getting more bigger, larger. So if you have been following DoD, like I said, I'm covering from the DoD side, the DoD DevSecOps initiative, this has been instrumental in setting what the DoD wants to do. This is actually now reaching out to the civilian federal sector also. I know, for example, IRS is trying to do something like this. This document explains what DevSecOps is and why it's important and why we should look into it from a federal agency perspective. So how do we actually do DevSecOps? Right? A lot of people kind of get used to DevOps. What do we need to do DevSecOps? Well, we always say DevOps is a combination of people, process, and tools. What we are here up here, we can definitely provide the people. We can definitely provide best practices. What we're up here to talk about is the tools. The couple of keywords that you're going to hear from the needs is CI, CD, and continuous learning and monitoring. So when I talk about CI, we're talking about basic principles of software development. CI stands for continuous integration, and the idea is basically developers developing code and pushing it into a central code repository as much as possible, and actually leveraging test-driven development and things like that. Continuous delivery is about how can me as a developer deliver applications directly into my environment. So a lot of times, people say my production environment is disconnected. I can't really deploy directly to my production environment. We're not talking about delivering directly to production, right? We're talking about just delivering it to an environment that can be tested. So, for example, in some cases, if your production environment flies, for example, you don't have to deploy it every day to a fighter pilot. You can actually go ahead and deploy it to a test environment. You can go ahead and deploy it to a segregated pre-production environment. That could also be a continuous deployment. And the last thing is basically talking about monitoring and learning, right? We're not going to be able to make a lot of changes in our DevSecOps model if we don't actually continue to monitor what we're doing and how can we get faster. So say, for example, today we're deploying something to production and it takes us an hour to do. But we want to actually gain improvements from it. There's no way we can actually gain improvements from it if we don't exactly monitor it. We also actually want to do continuous monitoring of the security protocols that are built into the platform. So those are the 3 pillars of what we actually need for DevSecOps. I'm going to pass it out to Andrew. He's going to talk about GitHub, and then I'm going to get back and actually talk about Azure.
Thanks, Harshal.
Yep.
See if we can use the fancy clicker today. Awesome. Yeah, so when we think about DevOps and DevSecOps, where are we seeing the most success stories? There was a great white paper that just came out, I think from ACT IAC, which is the Industry Advisory Council on IT and acquisition. There's a lot of great use cases and case studies from a few different agencies that talk about how successful they are with implementing DevOps for anything from change management to software development to becoming more agile to deliver services faster, whether those are government to citizen services or internal line of business services for their organization. There's a common theme that I saw in that white paper is that developers are driving a lot of this initiative. And what's happening is developers are bringing in new technologies, new tools and ideas, oftentimes faster than the organizations or the agencies can keep up. And we see DevOps has kind of evolved into this DevSecOps notion where we want to be agile, we want to bring in these new ideas, but we want to make sure we're doing it securely and bringing in security best practices through that process. And we're seeing this across the board, not just within the federal government space, but across commercial sector as well, where developers are driving that innovation. And where are developers going today? Well, they're typically going to GitHub. GitHub houses a pretty large majority of the world's open source software and also proprietary software that's being developed from Fortune 50 companies all the way to individuals that are just trying to collaborate on open source projects, large and small. And the GitHub platform itself has grown tremendously over the last almost a decade since GitHub was founded. And if you ever look at the web archives, it's really cool because GitHub's user experience, while the UI has been updated a little bit, that core function that has made GitHub so popular for managing source code built on the Git technology and tracking issues and pull requests, that core function hasn't really changed because it's so popular and it's so wildly successful for development teams and organizations that are looking to adopt these methodologies at scale. So if you just look at the sheer size of GitHub and how most folks equate GitHub to housing popular open source projects and repositories that are kind of at the crux for DevOps enablement, anything from containerization projects like Docker or Kubernetes to machine learning things like TensorFlow, GitHub is really housing a lot of these communities. And over the last decade or so, we've taken the learnings from these communities and we are helping to enable organizations large and small adopt them so they can use those same methodologies and best practices that the most successful open source communities are using, but within their organization. So these numbers are probably already out of date since the last time I checked. So since this conversation here is about DevOps and DevSecOps, how does kind of GitHub fit into that picture? And I'll caveat by saying this is just one approach, one opinion. There's a lot of different conversations, as we'll hear from the panel, around DevOps, and it's different for every agency or organization. But this is just one such approach at a high level that we've seen in terms of the learnings from some of our users and customers today. But I want to start with an approach that's not so great. How many folks are working in a mid-sized, large organization today that are confidently strong DevOps adopters? You're doing DevOps, you have continuous integration, continuous deployment, you're working across different teams, or do you still kind of work in silos potentially, or don't necessarily have that type of collaboration that you may be after within DevOps? How many folks are strong DevOps? I'm like a DevOps guru, okay? I was hoping it'd be more hands. No worries, no worries. But how many folks want to get to this agility that DevOps and DevSecOps provides? Awesome, more hands. So let me talk about a couple of approaches that hopefully you can maybe steer away from that we've seen organizations start to adopt on this journey or start to embark on this journey with that haven't necessarily been as successful as they like, or they've kind of started back at square one while spending time and effort and potentially dollars on these approaches. So DevOps being developer teams together, traditionally with operations team kind of working together, breaking down barriers. But at the same time, oftentimes, they're not really breaking down those barriers. So they're maybe collaborating a little bit more, they're exchanging a few more emails, but there's still too many internal inhibitors to that type of collaboration. There's too many internal silos, there are too many political barriers or process barriers that are really slowing down their ability to collaborate. So we oftentimes see organizations that want to collaborate faster and want to produce software faster to the point where commercial entities, as you'll see shortly, are shipping software daily, multiple times a day. But it's still taking them many months to kind of work together and set up that type of collaboration, and they're really not being successful with that because it's still taking too much time. So that's one of the first problems. And the second problem is they're taking this approach in kind of a waterfall method in terms of their release management. So they have one approach in terms of their development environment, and then maybe a completely different approach when it comes to testing. And oftentimes you see the boxes a little bit smaller. Testing doesn't really emulate the dev environment, and then oftentimes it doesn't emulate the production environment, when in reality these environments should all be the same. They should all be able to replicate what you would expect to see in production, and platforms like Azure make that really easy to do. And then, of course, you have your staging environment, which, okay, now you have maybe another team that's involved and maybe security starting to get involved. But then when it comes to deploying into production, when we talk about successful DevOps entities that are deploying into production multiple times a day, they don't wait to stick in security between staging and production. And this is where a lot of organizations are getting hung up, in that they're waiting until kind of the last minute to do application scans, or they deploy the app and they only have operational security scanning practices, when the majority of vulnerabilities oftentimes result in the lines of code that are being written long before the app is brought into production. So they don't have kind of this cohesive working methodology. And oh, by the way, this time oftentimes extends when you look between these different environments, and these teams are just not working together to successfully deploy and establish a good working relationship across their entire software development lifecycle. And then furthermore, you have a lot of organizations that, all right, they're going to start collaborating, they're bringing in the ops team, but developers may have a lot of great knowledge in managing their artifacts, like their source code, but oftentimes DevOps dictates that you have to manage your infrastructure in a very similar way. And the operations teams and infrastructure folks just don't have a solid foundation for doing that. Or if they do, they're not really collaborating in a way that they really could be with the development teams that do have a strong foundation. And the classic example of this is infrastructure as code. How many folks have heard of this term, infrastructure as code? Awesome, that's a good number. For folks that don't know what that is, this is a way to use software artifacts to manage your actual infrastructure and deployment from a command line perspective or from an artifact and state management perspective. Rather than going in through the UI and walking through your deployment mechanisms, you can use command line tools and artifacts to actually manage your infrastructure in a similar way to developers manage code. But one of the biggest problems we see is those operations teams that are embarking on this notion of infrastructure as code, because they see the value in that, they don't manage those artifacts in the same place their developers manage them, or they have a completely different process for doing them. And the same goes for security folks that are working on shell scripts or scan reports or audit templates. They're all working independently and thus going back to square one, which is they're still establishing silos amongst their teams. So the biggest problem we see here is that there's no reuse. We oftentimes have organizations that are spread thin, and they're rewriting the same artifacts and reusing the same code when that code is oftentimes either available internally by another team, maybe sitting next to you that has written that, or more importantly, out in the open, because oftentimes these artifacts are not super secret and they're not proprietary in nature. So oftentimes there's no reuse, there's no visibility, and you end up back at square one in terms of silos. And most importantly here as well, you're waiting too long in the development lifecycle to incorporate security best practices. So what does successful DevOps, DevSecOps look like? What does it look like for folks that are using GitHub or platforms like GitHub today? Again, this is not meant to be prescriptive. This is just meant to be kind of one approach or opinions on this. But where are we seeing the most success stories with DevSecOps, and what does that actually look like? Well, of course, it's bringing everyone into the fold early on in the process. It's identifying the mission needs and objectives and doing this across the entire development lifecycle, and having a shared platform to manage all of those artifacts in, and even bringing in non-development teams and non-technical folks into the conversation. Oftentimes, folks just equate tools like GitHub with development teams or even system administrators and operations folks, but it's a lot more than that. We have successful DevSecOps organizations today that are using GitHub and platforms like GitHub for far more activities that are part of the whole development lifecycle. Everything from change management, process and policy management, and the like. And by having a single platform to manage all of these artifacts in, you're immediately opening yourself up for reuse and greater visibility across the organization, such that when another team wants to deploy a project or establish a development lifecycle, they already have a good starting point to do that, and they don't have to start from scratch at square one. And of course, this process repeats itself throughout the entire development lifecycle, and all of the release phases of your application, whatever that may be, are the same from a compute perspective and the same from a development approach perspective, and allows you to deploy your applications much more quickly and securely from the start. And so we talk about, and you'll see this kind of in the demo, it really revolves around the notion of being able to contribute a change through a feature which we call a pull request, and driving that entire development lifecycle, inclusive of security, from the moment that pull request is created to make a suggestion, all the way through the merge of that pull request and through to the deployment of that application, wherever that may be. So really, everything becomes code. Everything becomes one central place to manage these artifacts. And now you're opening yourself up for greater visibility within the organization. One of the most successful things that we see, especially within government, is that by default, an agency is providing its source code within the whole agency as read-only. So they make it entirely available across the entire agency, with the exception of a few projects here and there as are needed. But it really opens themselves up for better visibility and better collaboration, because folks can go out and do that introspection and search for projects that may have some code or dependencies that you want to leverage. And of course, security at every phase of that process. And we have many, many lessons from the disruptors, quote unquote, those out in commercial space that are really driving kind of this gig economy, this app service economy. We all expect kind of the latest and greatest. We want it on demand and as a service. And how do you do that? Well, you have to be able to iterate faster as a company. We have organizations that are pivoting themselves, and almost all enterprises today are becoming software companies as a result. And many of these names that you see here, you may already be using those services, and they oftentimes release updates to their applications and services multiple times a day, multiple times a week, and they're really doing these things successfully. They may not take that exact approach that I described there, but they're able to iterate faster and have one place to manage all of those artifacts. And these entities are all users of GitHub today. So how does GitHub kind of enable all of these things? And I'm going to show a demo that highlights each of these areas with a predominant focus on security and code to cloud. But GitHub is really focused on these pillars for enablement and making it easier for you to adopt a lot of these workflows. And all of these things are driven around community. So we don't like to reinvent the wheel, because we have a community of developers and open source evangelists that are building these things day to day and volunteering their time and resources. So we've built a lot of our solutions and services around community-enabled approaches. And when we look at security and compliance, community is really the only way to tackle this challenge. And it really is an existential challenge to building software and being able to deliver your services faster. And if you look at some of the top security breaches that are out there, they almost always start with vulnerabilities in the software. You can have all of the perimeter protections in the world, but a SQL injection attack is still a SQL injection attack, because you have poor UI and poor front-end code. And there's many, many different vulnerabilities that are out there that are nearly impossible to keep up with. There's some statistics out there from PwC about the exponential increase in vulnerabilities, how it's almost impossible to keep up with these things. But what are we doing at GitHub to kind of make this easier, since we are this platform for the majority of the world's open source software, and we have millions of users and millions of repositories? Well, it's all about shifting security as far left in the development lifecycle as you can. If we can shift security to the moment the developers are writing lines of code, or the operations folks are managing infrastructure artifacts, we can significantly reduce the impact as a result of any sort of vulnerabilities that are discovered throughout the software supply chain. And this is actually from some of the NIST documentation and standards that are out there that talk about your exposure as a result of waiting until deploying all the way into production before discovering vulnerabilities. And there are many examples of this today. But at the same time, how do we do this? Because the developer community today predominantly consists of software developers. These are folks that are bringing solutions together and bringing in dependencies to build common things like web apps and APIs and mobile apps. But the community of security researchers that are going out and finding these vulnerabilities is a lot smaller. Some of the statistics show millions versus a few thousand. So how do we kind of bridge these two together? And that's what we're doing within GitHub today. And we make all of these capabilities pretty much available at no cost within the GitHub platform for open source work. Everything from dependency insights to being able to manage dependencies for open source libraries that you pull down as an organization or as an open source contributor, to vulnerability management. We have a whole static code analysis solution. You'll see all these things here shortly in the demo. And also, a lot of people overlook this, but better providing incentives for folks that are going out and volunteering their time for open source projects. It's one thing to pull down an open source library into your project, but how do you know that the maintainer of that is volunteering their time and they're happy about that time that they're volunteering? What are the incentives for them for doing so? And that's something that we've launched with GitHub corporate sponsors, where they're now incentivized to go out and build some of these solutions and still contribute back to the community. And you'll see some of these in the demo here shortly. So along with security and compliance, another big focus of GitHub, or GitHub's for enabling CI/CD and software development is better enabling some of these agile workflows in pipelines. And of course, CI/CD is kind of core to that, as Harshal mentioned. Because we want to be able to deploy faster, and we want a really easy way to be able to ship our software and spend less time kind of managing these workflows from a manual perspective, or writing shell scripts, or hopefully not dragging and dropping files to folders that may represent your production environment. So we're really about enabling the time between releases, the time between deployment, and enabling faster iterations in the software lifecycle. And there's some capabilities in GitHub that, if you have been using GitHub, you may have seen some announcements around these that really help kind of enable these workflows. So tools like GitHub Actions, which is a CI/CD pipeline engine similar to other tools you may be familiar with, and packages for managing these package dependencies, and you'll see this here in the demo as well. All of these things, again, are built around community. In that Actions, you can build CI/CD pipelines using community-built workflows. You don't have to start from scratch every time. And the same goes for packages. You can go in and pull out precompiled and pre-built dependencies for the applications that you're building. And then the last two things are really GitHub's bread and butter around enabling a better community and fostering a better community for collaboration and innovation. And this is arguably what has made GitHub so successful over the last decade or so, in that we already have the learnings and the best practices and approaches from some of the most popular and successful open source communities that are out there. And they're using the simplicity that GitHub provides, using tools like issues and project boards and pull requests to enable these types of collaborative workflows. And what we're doing at GitHub is we're taking those learnings and we're bringing them in from an enterprise perspective to better enable large organizations to abide by and adhere to some of these same practices, so they can be just as successful in the way that they collaborate and deploy their software. And we coined this term inner source, which is kind of like open source, but taking these same methodologies and bringing them into your organization for better collaboration and breaking down those silos. And developer talent. If you're a large organization or an agency, how are we going to find developer resources or software engineers to kind of assist in this? Where are they coming from, and what are the tools that they're using to do that, and how do we retain that talent? Well, as you saw from the numbers from a few slides back, most folks are familiar with GitHub. They're using GitHub to establish a resume of projects and open source libraries that they're building, and it provides a really good portfolio for showing that so that you as an organization can figure out, all right, do I need developers for this type of activity? How can I leverage these resources in this way? And we see a lot of corporate sponsorships as well, where organizations, again, are using GitHub sponsor programs to enable open source contributions from a contractual perspective. So, of course, there's a pretty large demand for software development talent, and a lot of folks are looking at GitHub to helping fulfill that demand from a resume perspective or a portfolio perspective. And, of course, GitHub has become this global community for a lot of these things. So I want to highlight a few of these things that I talked about in a little bit of a demo here. And hopefully it'll kind of bring these things together. So how many folks use GitHub every day? Okay. How many folks have never used GitHub, period, or have never seen GitHub? Okay, a couple. So I'll walk you through just kind of the basic GitHub interface for folks that haven't. And again, if you look at the web archives, it's pretty cool because the core user experience that GitHub provides hasn't changed too much. And like I said, it's what has made GitHub so popular. GitHub is a hosted service. GitHub.com is the website most folks know and love. This is what one of the pages looks like that hosts source code. Everything is built on the Git version control tool, which is a decentralized version control system, if you're not familiar with that. It's a way of managing your code, but while instead of everyone contributing to the same central repository of code or checking in and checking out code, everyone manages their own full copy of that software, and they push back to the main copy by facilitating reviews and pull requests, as you'll see here shortly. So this is a piece of software. This is, I'm not going to go into the software too specifically, but this is a multi-framework, multi-language application. It uses a paradigm known as microservices, which has become a pretty popular paradigm for agile development and used oftentimes in DevSecOps workflows. The cool thing about this application is it's built in actually multiple languages. You can see here Java, Go, C#, JavaScript, and a few other artifacts. The beauty of GitHub is that GitHub can store really any text-based software artifact for hundreds of different languages with included support for syntax highlighting. And it just goes to show you the power and the flexibility you have to use GitHub for anything from software development to text-based development, research, and traditional writing as well. Now, in this repository, there is also a tab for issues, which allows me to create new issues and new work items to track different activities for a project. Now, this is a demo. I don't have any issues here, but let me show you a more active repository with a lot of issues. This might resonate to some folks. How many folks know what the National Institute of Standards and Technology is, or NIST? Awesome. They, of course, build standards and compliance frameworks for the government. Well, this is a project that NIST is working on entirely in the open and using GitHub to do it all. This is a new standard that they're developing, and they're building it completely from scratch using GitHub and using issues to track collaboration both amongst themselves and then also with community collaborators. These are what issues look like. They have a title and a description as to what you're trying to fix, what you're trying to manage, and what you're trying to propose as a feature. So maybe I'm a new collaborator on this project, and maybe I'm not a developer, but I'm trying to use the standard for my compliance processes, and I notice there's a documentation bug or a feature that I'd like to see. Well, an issue is a way to kind of collaborate on that type of conversation and propose new features, request new things, and have that dialogue with the folks that are involved in managing this project. And you can see that here. This is an issue that's been created by one of the community collaborators. Organizations can set up templates so they can manage predefined artifacts for these issues. And this is kind of the core bread and butter for GitHub itself, and has been a core capability for quite some time. Now, if, let's say I'm a developer or a technical individual and I'm actually working on this project because I want to use it for my own organizational purposes, or I'm contributing a new line of code to this project, how do I actually make that change and contribute it back to the project itself? Well, this is another core feature of GitHub itself through what we call a pull request. A pull request is saying, hey, I have a suggestion that I'm making to this project. If you review it and accept it, I'd like you to pull it into the master branch or the central branch for this project. And you can see here there's an open pull request that was submitted by myself for this particular project. And the pull request, as you saw in a few slides ago, is really what drives the whole DevSecOps workflow in the context of GitHub. Because the pull request gives you that full traceability from the moment you have the idea or the bug fix or the security fix for testing and deployment and incorporating new security capabilities all the way in through traceability for your deployment and release management. So this is a pull request that makes modifications to a couple of lines of code in the application. Like I said earlier, this is just a web application with a couple of different APIs. It's a fictitious application for tracking resources or IoT resources in a hosted app environment. But one of the things I want to highlight in this pull request is that GitHub provides the capability to automate a lot of the core checks you need as part of that CI/CD and secure workflow. And you can see that when this pull request submitted, there were 13 checks that were run and defined by the project owners that identify all the steps that need to be checked for. So anything from unit testing to functional testing and integration testing, and also security code scanning. And we talked about shift left security, which is how do I ensure that my application is secure from the moment I write the line of code. I want to ensure that GitHub can actually scan that application and ensure that the code is up to best practices and secure coding principles. So you can see here, this particular pull request has failed. There were a few checks that were not successful. And I can go in here before this pull request is merged into the project, and I can see what failed as a developer and figure out what I need to do to go in and address it. Now, another aspect of this is a security aspect. And this is kind of a sneak peek. This is something that isn't fully available yet in GitHub. So if you are using GitHub pretty regularly, you may not see these tabs on the left. One of the things that we provide in GitHub is an ability to scan your project for source code dependencies and ensure that you're using libraries without known vulnerabilities. This is a capability that you do have available in GitHub today. And if you're using one of the languages that we support for this function, you'll see that it's automatically picked up a dependency in my project with a known vulnerability. And you can see here that I've dismissed it because I know that in this case, it's an issue that I'm assuming the risk for. And you can see that GitHub has automatically provided remediation steps in the software and a direct link to the CVE as well. So again, shift left security, moving security as far left as we can in the software development lifecycle, rather than waiting for and scanning this vulnerability at production deployment time. Now, one of the other cool things that GitHub can do is that we can not only notify you of the vulnerability that's been detected, we can automatically submit a pull request, which again is that proposed change. We can submit a pull request automatically on your behalf with the actual code change that's needed to fix the vulnerability. So without any human intervention or manual intervention, we can actually propose a change to fix the vulnerability such that all you need to do is review it and merge that pull request in. And there's some statistics out there that talk about the time in which a vulnerability is detected to when it's actually addressed is oftentimes weeks or months. And in many cases, it's as simple as bumping a number in your dependency listing. So some cool capabilities there. And this is something that we haven't made available yet, but this is part of a capability that is being made available through an acquisition that we made a couple months back for static code analysis and testing. So this may not resonate if you're not a software developer, but again, shift left security. If you are building software and writing code, we want to make sure that from the moment you write the line of code that it's being scanned against best practices. So you can see here that this static code tool has detected things in your code that aren't up to snuff or not right or not secure practices. In this case, this is a function that's never actually executed. It's just kind of a blank statement. And we're going to be expanding upon these capabilities pretty soon. Now, assuming that all of these checks have passed, one of the other things that GitHub enables is kind of deployment all the way into your staging and production environments. And you can see that here if I look at one of my other pull requests. I'll go to my master branch. Actions here. So this is one of the workflows that GitHub provides capabilities for in terms of automating your deployments into your environment. So once I've merged that pull request and all the checks have passed successfully, I can trigger a workflow that automatically deploys the app into my staging or production environments, again, ensuring that we have full traceability throughout that entire application lifecycle. And these are the steps that we're in as part of that. Now, how do you actually define these steps? I talked a little bit about how GitHub should be, or you should have one place to manage all of your development artifacts and your infrastructure artifacts. Well, all of these steps are actually defined by, let's say I have a fictional operations team that can define the deployment lifecycle of this project. And they manage that code right alongside the rest of my artifacts, as is defined here. So I have one place to manage the actual application and the deployment of the application and the security of the application, and all of those teams that are responsible for those aspects of this application or this of this objective can all have one place to collaborate and manage these facets. And this particular workflow deployed everything into Azure, which I'll turn it over to Harshal to talk a little bit more about.
Thank you, Andrew. So what Andrew just talked about was basically DevSec, right? How do we bring security to developers? How do you enable the developers to think about security first as they're actually developing? So how does that apply to Microsoft? Like, what does Microsoft bring to the table? Well, Andrew talked about how you can actually bring in source code from any language that you want as long as it's text-based directly into GitHub. It's an open, flexible platform. That's exactly what Microsoft is. It's basically it's a flexible platform. You're not constrained by one technology stack. You can go ahead and bring in code that's written in .NET, Java, Go, Ruby, Perl, Python, however what you want, and you can actually bring it to Microsoft Azure, and you can run it. We're talking about powerful. We're talking about hyperscale, right? So basically, we're talking about like millions and millions of cores being able to run in our data centers. And then open, we've already talked about that. So one of the biggest issues when we talk about like DevSec is fine, we have an artifact now that has been verified through the process, through the pipeline. Where does that artifact go? Now, we talked about one of the biggest issues is siloed environments, how each and every environment is different. How when I deploy to dev, that goes one way. When I deploy to test, it goes one way. And production, half the time, doesn't work. When we talk about basically cloud hosting applications, you have options. A lot of the things that you guys are doing right now, if you're talking about doing on-prem, talking about doing infrastructure. And infrastructure is basically set up like, hey, I'm going to go ahead and manage my own virtual machines. I'm going to go ahead and manage it, update it, and do all of that. As you see the orchestration, as you see the trends coming in, a way to enable DevSecOps is being right up here. Andrew's demo goes directly into a platform called Kubernetes. It's a widely most popular open source platform, and it's basically a container orchestration platform. A lot of our customers are also leveraging several PaaS technologies, and what you get from there is basically you don't have to worry about managing the infrastructure. You get a consistent environment across domain boundaries. So what I mean by that is, like, say, if you actually deploy something to a FedRAMP low or FedRAMP moderate environment, and you can take that same deployment and deploy it into a FedRAMP high environment. And if you're talking about DoD, you're talking about like an IL4 deployment, or if you're talking about IL5 deployment, or you can actually take the same deployment and go to disconnected. We have consistency. And that's the biggest thing in actually implementing DevSecOps, is a consistent environment across domain boundaries. So Andrew highlighted this about infrastructure as code, about how we can actually leverage GitHub. As a matter of fact, if you actually Google, Bing, however you want, but if you actually look at Azure templates, there's actually a GitHub repo for everything that's there. Microsoft Azure actually supports open source technologies like Terraform and Ansible for actually doing infrastructure as code. So this is another way of actually making sure your environments are consistent across domain boundaries. I can actually go ahead and create code files for my environment, check it into GitHub, use GitHub to orchestrate it, and have a consistent environment across domain boundaries. So we talked about dev, we talked about SecOps. Yeah, thank you. We're talking about ops, about continuous monitoring, right? It doesn't add any value to actually deploy something and not actually monitor it. So a lot of our customers are actually using New Relic and things like that, but actually that requires additional licensing. What we have is tools baked into the product itself to actually allow you to actually do continuous monitoring. And the main value of this is, again, what we talked about initially, is about learning from the mistakes that most developers are making. So this is basically just a dashboard. I don't think I'm going to have time to actually do a demo, but it's just a dashboard about your application that's actually running in production. It basically brings you a bird's eye view of what your application is doing, from requests coming in to back-end database transactions. This is extremely helpful as you actually migrate more and more applications into Azure, because now you can actually see where things may go wrong. And then we also talked about continuous security. So basically this is about kind of how can we provide machine learning capabilities and advanced security features to our security stack, right? So basically we have products like Azure Security Center that actually hooks in with our PaaS platforms, hooks in with our Kubernetes platform, and actually provides you vulnerability scans. So similar to what Andrew was talking about within GitHub, how we can actually analyze the source code and actually provide you vulnerability scans and reports like that. This thing can actually do the exact same thing, except it actually looks at your production environment and provides you things that you should patch, gives you recommendation for like things that may be wrong. So finally, we're talking about basically deploying continuously and compliantly, right? So basically, the main thing that you get from Azure is, again, a consistent environment across domain boundaries, and all the tools that your developers need to actually have consistency and actually have continuous monitoring built into it. Any questions? I know. Do we have more time to go through demo, or is it?
You have time.
So one of the things that Andrew talked about was containers, right? So Kubernetes leverages containers. His demo creates and builds containers and pushes it off to Azure Container Registry. So this is the managed container registry available in Azure right now. And as you can see, it has integration with the two of the greatest security companies right now, Aqua and Twistlock, and actually helps you inspect your containers as it's actually going in to Azure Container Registry. So this is what you're seeing is basically a real-time Kubernetes cluster. You can see it's actually changing. It's actually a real-time dashboard that's actually built on a technology called Application Insights. It is extremely easy to implement within your source code. It's basically usually sometimes it's just basically a library change, but it collects telemetry data, and it allows you to kind of like helps you visualize it and helps you kind of like figure out what's going on with your application. Again, if you are talking about DevSecOps, this is extremely critical from a monitoring perspective. You cannot actually do migrate application and actually find what's going on without this. So what you see up here is basically, this is a security center. Kind of spoke about it a little bit earlier. So I have a Kubernetes cluster, 2 Kubernetes clusters up and running in Azure. Once I click on the Kubernetes cluster, what you will see is it gives me all the details, but it also gives me a recommendation list and says, hey, I have high vulnerabilities in my Kubernetes cluster, and I should fix them. I can go ahead and click on it. What you will see is you say, here is the threat, and it will also give me remediation steps, and also with links. So it's basically using machine learning behind the scenes to actually go ahead and capture all this. And lastly, we're talking about basically is monitoring. It's another monitoring solution, but in this case, it's actually monitoring your Kubernetes clusters. So again, I keep on talking about Kubernetes more and more because that's where we see our market trends going. That's where we see our customers actually want to go. Not saying that every single application that you have is containerizable, but that's where what we see is basically our greenfield applications are going. Okay, I think that's all we had. I think we finished right on time. Any questions? If not now, later on we'll hang around. Question? Good.
We can take questions.
Yeah.
Just a second.
With respect to GitHub?
Yeah.
Someone wants to
Andrew,
answer that?
So Azure repos with respect to GitHub. So the direction that we're getting, and add to this, but the direction that we're getting is GitHub is our future, and it's going to be the future for the company. But Azure repos is not going to go away. So what does that mean? That means that if you are an existing Azure repos user, you can continue to use it, but do look into GitHub and all the security features, because a lot of the things that Andrew talked about today are not going to be part of Azure repos.
So basically you're saying all the goodies are going to go to GitHub?
Yes. So as a company, we are heavily invested in making sure that GitHub is the product of our future.
Yeah.
Testing. Yeah, so I think it's important to get on the same linguistic page as the accreditation folks, at these agencies that we're working with. When you say a term like artifact, I understand completely what you mean in context, but that means something very different to the SANA people that are putting together these accreditation packages. When we talk about the automated deployment, what they hear is just complete terror. How do I know, right? And we've all had these moments where we've tried to explain to security people technical concepts that they just simply aren't familiar with. I remember being asked for the RACL of virtualized systems, years ago, before that was a thing, right? So my question really is just how do we bridge some of those gaps? How can we, somehow we have to get the people the gatekeepers to understand.
I'll just start.
Absolutely. So dealing with I would say education has been one of our biggest things in educating our customers and educating especially the security folks in the terminology, in the lingo, and what it means when we talk about continuous deployment. And the main idea is because these are the folks who have been doing the same thing over and over again in an on-prem environment for a really long time. And getting them to change the mindset that the new technology allows you to do things better and differently. Another thing is basically a lot of times they feel like it's their jobs on the line if they approve something that they don't understand. And getting them to understand what they're actually signing off on is extremely important. And tricky, yeah, absolutely tricky. And it's never a fun conversation. I've had people, after a 2-day workshop I've done on PaaS technologies, tell me, can I get RDP access into your PaaS environment? Yeah, and so again, like I said, it's a tricky conversation, but like the best thing you can do is you can continue to educate the customer.
Yep. I would also add too, I mean, find ways that you can make their job a little bit easier. Oftentimes, security and compliance folks, I mean, I've written SSPs myself, and that project, by the way, I can highlight as well. There are really some cool things that are making security and compliance a lot easier for their world, such that they're, instead of spending time writing 1,000-page Word documents, they can use some of these same tools that development teams and operations teams are using to actually automate some of those processes as well, but doing so such that it still gives them, it doesn't push them into kind of the fold too much, and it doesn't give them too much risk in the early goings.
Yeah, and another thing just to add is like, so the idea right now, what's been happening is they're pre-ATOing a platform. So what that means is basically pre-ATOing an OpenShift platform or pre-ATOing an open source Kubernetes platform and getting that ATO'd. So anytime an application is actually deployed to a pre-ATO'd platform, you don't necessarily have to re-ATO the whole platform. So there has been some changes in Fed space, especially on the DoD side, where there have been exceptions where now I'm making microscopic changes inside a pre-ATO'd platform within a certain domain boundary. Questions?
Are the new services you talked about, are they going to be available on enterprise or
Enterprise as in like enterprise server?
on-premises or air-gapped?
Yep. Yeah, so all these capabilities are making their way into enterprise server, and we'll have some cool new offerings that you'll hear more about over the coming year. So we actually have 2 different environments. We have Enterprise Cloud, which is our hosted SaaS. That is a FedRAMP tailored authorized SaaS. It's great if you're already using GitHub today as an agency, and since you're already assuming the risk, it's a great way to kind of merge into that boundary with little technical effort. And then all these same capabilities are making their way into enterprise server if they're not already there for air gap use cases.
Great.
So out of GitHub Actions, which is actually really more in the Azure DevOps pipeline?
Yeah, as Harshal kind of alluded to, a lot of those core capabilities are coming into GitHub Actions. In fact, behind the scenes, Actions actually uses Azure Compute Infrastructure and Azure pipelines to power some of Actions, although that's abstracted from end users. But yeah, all those core capabilities that you may see in Azure pipelines today, they are coming into GitHub and GitHub Actions. That is inclusive of traditional CI/CD and also release management and release automation as well.
Great, thank you
Maybe
guys.
cap on questions. Thanks.